Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is object-oriented programming, and the same chapter, that is the introduction to the STL, that is the standard templates library. In the last class we have continuing with this chapter, that is introduction to STL, and some theoretical topics related to the container, related to the vector, related to the DQ, set, multiset. So we have studied about theoretical subjects of the or theoretical topics of the STL, right? And we have also studied one example, one program of the container, that is a sequence container, right? So let's continue with the previous class session, then move to the today's class session. So let's continue with the previous class session. In the last class we have started with the container. That is containers are the objects that holds the data of the same type. So whenever we want to whenever we want that the multiple objects are combined together, multiple datas are combined together, that is combined into a container, and these are nothing but the objects. So these are the objects that holds data of the same type. The STL defines 10 types of containers. So there are total 10 types of container that is available in the STL, that is a standard template library. But for convenience of the user, for convenience of the customer, it is brief divided into three categories, that is a sequence container, associative container, and the derived container. And in sequence there are three parts, associative there are four parts, in derived there are three parts. 3 plus 4 plus 3 is 10 only. And then we have discussed about the containers and how they are supported with each other, what are the header file that is used, what are the iterators that is used. So the container name is vector, and the description is it's a dynamic array that allows the insertion, deletion. Then there is a header file, which header file is used, that is a vector. We have studied one example also in which the vector file is used. And iterator means the pointer that is used. It is a random access, so we can randomly access, we can choose any option, any method that is used for the insertion and the deletion of the method. Then the next container is list, then DQ, set. So these are the multiple containers as well as their descriptions, header files, and the iterators that we studied. This is the table. Then we have studied about the sequence container. That means one after the another elements are clubbed together, elements are combined together in a sequence. That is a sequence container. Sequence containers store elements in a linear sequence like a line. Every element or the each element is related to other elements by its position along the line. So every element is related with another element by the line. They all expand themselves to allow insertion of elements, and all of them supports a number of operations on them. So there is a element 0, element 1, element 2 till last element. So it starts with the begin. This is the begin. There is a iterator. There is the end. That is ending of the element. That is the last element. So these are the elements in a sequence container. So STL provides three types of sequence container. There are three types of sequence container that is available. One is the vector, then DQ, then list. So there are three types of container. That is a sequence container that is used. That is vector, list, and the DQ. And these are the various algorithms that we have studied in the last class. That is a fill n, generate function, generate n, iterator swap, remove if, and these are the various sorting algorithms like binary search, equal range, in-place remerge, merge two consecutive sorted sequences. Then these are the various set algorithm, that is how to set the content, how to set the sequence, how to set the numeric values. That is the includes algorithm, then set difference, set intersection, set symmetric difference, then set union. So these are the multiple set algorithm that is used. Then there are some relational algorithms also that is used, that is equal, max, min, max element, mismatch. Then there are some numeric algorithms like accumulate, inner product, partial product, and the adjacent difference. So these are the various we can say that these are the various algorithms that is used along with their descriptions. This is a table. That means standard template library contains these types of algorithms, containers, iterators. So just imagine, this is a STL is a very huge concept, complex concept in which we everything is stored in the STL. But we as a user simply focus on few topics or the few algorithm, because we are bound to the limit, we are bound to the size of the pages. There are so many limitations that is available, right? But STL is a very huge concept, broad concept, right? Then the next topic that we have discussed is the iterators. That is simply nothing, or that is simply a pointer that is used to point the object. So it is nothing but a pointer. So iterators points or behaves like a pointer and are used to access the container elements. They are often used to traverse from one element to another element. A process known as iterating through the container. So iterators are the nothing but the pointers and are used to access the container pointers. And these are the various iterators. This is a table that shows various iterators and their characteristics, that is along with their features. So there are iterator name is input, and the access method that is used is a linear. Direction is forward only. So this iterator can move only in the forward direction. The input output capability is read only. Then remark that cannot be saved. That is that this iterator cannot be saved. Then the next iterator is output iterator. That is also a linear, that is covered only in the forward direction. Then this is the write only, we cannot read the data, that cannot be saved. In the same way forward operator, in the same way bidirectional operator, in the same way random operator, iterator. So these are the various iterators that is used in the, or that is stored in the STL. And the bidirectional and the random iterators can move both in the forward and the backward direction. And the input output capability is that is there is a read operation as well as the write operation, and it can be saved. Different types of iterators must be used with the different types of containers. There are multiple types of operator that can be used with the multiple types of containers. Note that only sequence and the associative containers are traversable with iterators. Each type of iterator is used for performing certain functions. So there are multiple iterators that we have studied. This is a diagram that shows there are multiple iterators. One is a random access iterator, one is a bidirectional iterator, one is the forward iterator. So in the forward there are two parts there, that is the input and the output. So the input and the output iterator supports the least functions. They can be used only to traverse in a container. So these are the various operators that contains the various functions, least function that can be used to traverse in a container. The forward iterator supports all the operations, that is both the input output operators as well as the position in the container. So there are multiple input output iterators support only the least functions, that is they are traversed in a container only. But the forward that is used, that supports all the operations of the input and output operators and also retains its position in the container. A bidirectional supports both all the forward direction operators as well as the ability to move in the backward direction also. So we can say the bidirectional contains a forward iterator. Why? Because forward only moves in the forward direction, but bidirectional iterator moves in the forward as well as the backward direction, right? Then a random access iterator combines the functionality of the bidirectional as well as the ability to jump into the arbitrary location. And these are the various operations that is performed by the iterators. So this is the input. What is the element access? This is a symbol that is used, that is the arrow operator. Then there is a read operation, there is a write operation, there is a increment operation, there is a comparison operator. That is, there are multiple elements. These are the multiple operations that would be supported, that would be performed by the iterators. Next, we have studied about the application of container class. That is, what are the various applications of container class. So in this, it is just focus on the sequence containers. So just focus on the three types of containers, like name, list, and the map. In the last class, we have started with the vector container, and we have studied about the vector container program about the vector container. So this is a vector, that is a vector container, that is a most widely used container. So most widely used container means most of the persons, most of the programmers, most of the developers uses this container, that is a vector. It stores the element in the contiguous memory locations and enables direct access to any element using the subscript operator. A vector can change its size dynamically and therefore allocates memory as needed at runtime. So it's a capability of the vector operator to change the size automatically at the runtime. So whenever the program is running, so vector operator or the vector container can change the size or dynamically and allocates the memory at the runtime also. The vector container supports random access iterators and a wide range of iterator operations that may be applied to a vector iterator. So class vector supports a number of constructors. These are the multiple objects that will be used. There is a vector int v1, that is a 0 length int vector. Then vector double v210, that is a 10 element double vector. Then vector int v3 v4, that creates a v3 from the v4. So these are the multiple declaration, multiple syntax that will be used. Then v52, that is a 5 element vector of 2s. Then this is the important function that is available, that is the important member functions of the vector class. There is a add function that gives only a reference to an element. What is a reference? That is what is the address point of the vector function. Then erase, that deletes the specified elements. Erase, insert, that inserts the element in the vector. There is a begin, there is a capacity, there is a clear, there is a empty. So these are the multiple member function that would be used in the vector class. So this is the program that shows how to use various functions in the vector class template. So it starts with the hash include iostream, that is a header file, and one more header file is included, that is a vector header file. Why? What's the reason? Because we are going to use the vector container, so it's mandatory to use the vector header file in the vector program. This is very much important. Then next is the same line, that is a using namespace std, then void display vector int ampersand of v. So display is the function and the argument or the parameter that is used is the vector int ampersand of v. Then the for loop will be used that start with the 0 and with the size, then I plus plus, then cout vi, then cout n. Then there is a int n, that is int main, that is the starting of the main, that is the main function. Then vector int v, so this creates a vector of the type int. So a vector will be created that is of the type int. Then next function, that is next part is putting the value, so simply use the for loop for putting the values. Then pushback function will be used. Now let's see what is the use of the pushback, that adds an element to the end. So for adding the element it is using, or here it is using the pushback function, so that the elements are added at the end of the point. Then again for showing the size, again the size function will be used. So this size function, this is most widely used, that gives the number of elements. So this is a function that is used in the vector. Then for displaying the content, the display function will be used. For displaying the value, there is a display function that will be used in the vector. Then inserting the elements, the insert function will be used. There is an insert function that will be used to insert the value, that is the insert elements in the vectors. Then there is a vector, then iterator, then again inserting the value, then deleting the value, that is the erase. Then begin function will be used, then display function will be used. So these are the multiple functions that will be used. So this is the begin function that gives a reference to the first element. So whenever we use the begin, that gives the reference, gives the address to the first element of the vector or first element of the list. This is the example. First of all, the initial size is 0. Now enter the 5 integer values. So there are total 5 integer value that will be entered in the container, that is 1 2 3 4 5 for example. So what is the size after adding 5 value? The size is 5. So the current contents are 1 2 3 4 5. Now size is 6, that is contents is now 1 2 3 4 5 because we are adding one more element. Then contents after inserting one more element will be inserted, that is a 1 2 3 9 4 5 6, that is a one element is inserting in the middle. Then one content will be deleted, that is the content will be deleted, that is the 9 and the 4. So the content after deletion is 1 2 3 5 6. So this is the explanation of the program that we have studied, that is how this program works. Now the next part is list, that is how to use the list container in the STL. So let's start with the list container. So the list is another container. So this is the today's topic. So list is another container that is properly or popularly used. So list is another part that is used in a most popular way. So one is the vector, one is the list. Right. It supports a bidirectional. Bidirectional means inserting and deleting the elements both from the forward direction and well as the backward direction. So it supports a bidirectional linear list and provides an efficient implementation for deletion and insertion operations. As I said you that it is a bidirectional, it also allows the insertion and the deletion operations very efficiently. Unlike a vector which supports random access, a list can be accessed sequentially only. So unlike any other vector that supports the random access also, but it supports, that is a list vector supports only the sequence operations only. So there is a vector that is in a sequence, that is it can be accessed, or a list can be accessed sequentially only. Bidirectional containers are used for accessing list elements. So bidirectional iterators are also used for accessing the list elements. That is the iterator that is used is also of bidirectional. Any algorithm that requires input, output, forward or bidirectional iterators can operate on a list. So any algorithm that requires a input, that requires a output, that requires a forward or that requires a bidirectional iterators that can operate on a list. Class list provides many member functions. So there are so many member functions that is available in the class list for manipulating the elements of a list. Important member functions are given in the table 14.12. Use some of the function in program, this one. So header file, yeah, this is the important line, that is a header file that is used is the list to use the container class list. So whenever we use the container that is a vector, so we use the header file vector. Now when we use the container that is a list, so we use the, or we include the header file that is a list. So this is the list, that is a header file that is included, that is a list. So this is a program that shows the how the list container should be implemented. So it starts with the hash include iostream, that is it starts with the header file, that is a hash include iostream.h, then hash include list, then hash include std or cstd library. So there is a library function that is used. So in comment it is showing that in this program we are using the rand function, that is a random function. So we are including the header file, that is a hash include std or cstd library. Then the line will be used, that is a using namespace std. Then the function will be used, that is a void display. So display is the name of the function and the void is the return type. Then the argument that is used is the list int ampersand of lst. So this is the argument, this is the parameter that is used. Then this is the explanation of this one, that is the list lst or list int, that is of int type. Then iterator that is used is the p. So the name of the iterator is p. This is the hidden page, so don't worry, I am trying to get it in the practical class, that is after the break. So this is the program that is not understandable by you because this is a half program. So this is the program. I will show you this program with the help of the practical class, that is I am writing this program on the Turbo C compiler. Now next is the table, that is an important member function, that is the table 14.12 that we are talking about. That is a table that shows different important member functions of the list class. So what is the first function? That is a back function that gives a reference to the first or last element. So what is the usage of the back function? This gives the element, or this gives the reference to the last element. So whenever I want to move to the last element, so we are using the back function in the list container. Then begin, that gives the reference to the first element. Then clear, that deletes all the elements. Then empty, that decides if the last or if the list is empty or not. So to identify whether the list is empty or not, there is an empty function that is used. Then there is an end function that gives the reference to the end of the list. Then erase, that deletes the elements as specified. Then insert, then inserts the element as specified. Then there is a merge, that merges two unordered lists. So whenever I want to merge two unordered lists, that will be merged by using the function, that is a merge function. Then pop back function, this is the important function that deletes the last element. So whenever I want to delete the last element, that will be deleted by using the pop back function. Then pop front function that deletes the first element. Then pushback function that adds an element to the end. So whenever I want to add any element at the end, that will be added by using the pushback function. Then push front, that adds an element to the front. Then remove function that removes the elements as specified. So if I want to remove the function, that will be removed, or if I want to delete, that will be deleted the elements as specified. That is, deleting the element will be done by using the remove function. Then resize, for resizing the element we have that is, if I want to modify the size of the list, that is, if there are total 5 elements in the list, I want to modify it to the 8. So the modification is done by using the resize function. Then reverse, if I want to reverse the list, that will be reversed by using the reverse function. Then size, that gives the size of the list, that is a size function. Then sort, that sorts the list. Then splice, that inserts a list into the invoking list. Then swap, then exchanging the elements of a list with who's in the invoking list. Then unique, that deletes the duplicating elements in the list. So whenever I want to delete the duplicating element, that I want only the unique records, that will be deleted by using the unique function. So this is the list container, that is a list container, how it is used, what are the member functions that is included in the list container, and there is a program that shows how to use the list container. Now the next container is a map container, that is a mapping the values, that is done by the map container. So a map is a sequence of pairs, that is a map is a sequence of two parts, that is a pair, that is a key and the value. So there are two parts in this, that is a map container, that is a key and the value, where a single value is associated with unique key. So there is a single value that is associated with the unique key, that is one value does not contain the multiple keys, only one value, one container, one value, one key. Retrieval of values is based on the key. So whenever I want to retrieve the value, that is based on the key. It is just like an array. If I want to get the array, or if I want to access the array, we are working on the subscript, or we are working on the superscript on the index value. So whenever I want to retrieve the value, that is based on the key, and it is very fast to retrieve the value on the basis of the key, which should specify the key to obtain the associated value. So we are using the values like value 1, value 2, value n, and there are multiple keys also, that is a key 1, that is a key 2, that is a key n. So this is the key value pairs in a map. So mapping means simply mapping the values from the value to the key. So there is a value, there is a key, that is a mapping is done. A map is commonly known as an associative array. As I told you that this is just like an array, so that's why it is also known as or commonly known as the associative array. The key is specified using the subscript operator, square brackets. So this is the key that is the whatever the key that is used, that is done, that is specified using the subscript operator that is known as a square bracket as shown below. Just like phone John equals to 1111. So this creates an entry for a John and associates or assigns the value 1111 to it. So phone has a value that is 11111, and phone is John is the name of the entry, and what is the value that is associated with it, that is a 5 times 1, and phone is a map object. So if I want to map the John with the 11111, that is done by the phone object. We can change the value if necessary as follows. So we can also change the values if possible. So if I want to change the value, this can be done like this one. That is a phone John equals to 9999. So there are 4 nines that is used. So that change the value of the John to the 9999 by using the this one, that is a phone mapping. So there is a phone that changes the value 11111 to 9999. So we can also insert and delete the pair anywhere in the map using the insert and the erase function. So this is the just a modification of the value. So we can also insert, we can also delete the function by using the map container, by using the map values. What are the various functions that will be used in the mapping or map container to delete or erase, or to insert or delete? That is the insert function and the erase functions. Important member function that is used in the map container are listed below. So this is a table that shows what are the various functions, what are the various member functions that will be used in the map container. So these are the various important member functions of the map class or the map container. So first function is begin. Again the same function, that is a begin, that gives a reference to the first element. So whenever I move to the first element, that will be done, that will be used by using the function that is a begin function. So we have to use the begin function to move to the first element. Then the next function is clear function, that deletes every element from the map. So whenever I want to delete each and every element from the map container, that will be cleared, or that will be deleted by using the function that is a clear function. Next function is empty function, that decides whether the map is empty or not. So this is just like a condition, that is a if condition or the while condition, that is checking the values if it is empty or not. So decides whether the map is empty or not. Then there is the end function that gives a reference to the end of the map. Then there is a erase function that deletes the specified elements. Then there is a find function that gives the location of the specified element. Then insert function that inserts the element as specified. So there is a inserting the function as specified, that is inserting the elements as specified in the container. Then size function that gives the size of the map. So whatever the size that will be available, that the map container, that gives the size of the map. Then swap, that exchanges the elements of the given map with those of the invoking map. So these are the various functions as well as their tasks, their description that will be used. So there is a begin, then clear, empty, then end, erase, insert, size, swap. So these are the various functions that will be used in the map class or the map container. Next is the program that shows the simple example of the map function, that how the map will be used or how the mapping will be used. Note that the map header must be included. So for the vector, there is a vector header file. For list, there is a list header file. For map, there is a map header file. This is the next topic, that is the function objects. So this is the various, these are the various function objects example, that is the STL contains the function objects. So first of all, there is a divide T, that is arithmetic. Yeah, we are doing the practical example that are hidden pages. As I told you, after the break we are doing the practicals on the list, map as well as the vector that we are studying in the last class. Don't worry, Larry. Okay, Larry. So these are the function objects, various function objects. There is a divide, then the type is arithmetic, that is the arithmetic operation will be performed. Then there is a description. What is the description? Arithmetic description is x is divided by y. Then equals to, that is equals to t, that is a relational type or the relational operation. And what is the description? That is the x equals to y, that is checking the equality if the x is equals to the y or not. Then greater t, that is also a relational operator. Then the condition is x is greater than y. Then greater equal, that is also the relational type. Then the condition is x is greater than equals to y. Then less, x is less than y. Then less than equals to, then logical, and that is a logical, that is a x and y, that is a multiple or the two. We can say the ampersand will be used. Then logical or, then logical not. So these are the various operators that will be used in the STL. These are the various function objects. So whatever the object, whatever the scenario, that the sign will be used. For logical and, this is the sign for the logical and. There is a double ampersand, this is for the not, this is for the or, this is for the minus, this is for the modulus. So nothing but what we have studied, the basics like modulus and not. So these are the various or, not, and will be used. So this is the divide function, this is equality, that is the equals to, this is greater than, this is greater than equals to, this is less than, this is less than equals to, and these are the relational types. And this is arithmetic first one, and these are the logical, that is and, or, not, or the are the logical types, that is the and, or, and the not. Then the minus, that is also arithmetic, modulus, that is also arithmetic, that is negate, that is also arithmetic, that is a minus x. Then not equals to, that is a relational. Then plus, that is a arithmetic, that is x plus y. Then multiplies, that is also arithmetic, that is a x multiplied by y, that is also a arithmetic. But not equals to is a relational type. So this says there is a note, the variables x and y represents objects of the class T that is passed to the function object as arguments. So the whatever the values, whatever the variable that is used, that is the x and y, these are the x and y that will be used, that represents the object of the class T that is passed to the function object as the argument. This is again the program that shows how the creator function will be used in the sort algorithm. So the header file that is used is the functional. So this is the header file, that is the iostream.h. Next header file is algorithm.h. Next header file is functional.h. So these are the three header files that is used. One is the iostream, then algorithm, then functional. Then there is a name space std, then there is the int main, that is the starting of the main. Then this is the int x, that is the array will be declared of the x. So x is an array that contains multiple values like 10, 50, 30, 40, 20. So these are the 5 values that will be available in the x array. Then int y, that is the y array, that the 4 values will be contained in this y array, that is a 17, 90, 60, 80. Now use the sort function for sorting the contents. right? That is x plus 5, then greater in, that is a greater function will be used for finding the greater, that is the greater. So first of all there is a x, then x plus 5, that is whatever the value of x that will be incremented by the 5, that is moved to the fifth location of the x, then greater int, that is checking the condition on the x as well as the with the fifth value, that is the fifth value of the x. Then the again the sort, that is a y and the y plus 4, that is sorting the algorithm with the y and the y plus 4. Then int I equals to 0, I is less than 5, I plus plus, then see out xi, that is xi means the array will be used, that is xi. Then see out n, then a for loop, again for loop will be used, that start with the 0, that ends with the 4, then j plus plus, then see out yj, that is 0 1 2 3 4, it continues till 3 element, that is there are total 4 iterations. Then see out slash n for moving to the next line. Then int z9, that is the array will be declared as a z that contains a 9 value. Then the merge function will be used for merging the values, that is x and the x plus y, x and the x plus 5, then y plus 4, then z. So these are the values that will be merged together. Then again the for loop will be used, that start with the 0, ends with the 9, then I plus plus, then simply prints the value, that is a z I. Then see out n, then there is a return 0. So these are the various values that will be printed. So first of all there is a value of the 50, 40, 30, 20, 10. So these are the various value for sorting the values. That is a first of all the higher value, that is a 50, then 40, then 30, then 20, then 10. And that the value will be printed. Then next there is the 60, 70, 80, 90. The four value will be printed with this one. That is a 60, 70, 80, 90. Then again the next one, that is from the y, that is the sorting operation. So for the x, this is the sorting operation, that is in the descending order. This is for the ascending order. Then for the z, there is a merging of the values, that is a 50, 40, 30, 20, 10. Then 60, 70, 80, 90. That is a merging of the x and the y with the use of the merge function. Right. So this program creates two array x and y and initialize them with the specified value. That is, there are multiple values, that is there are total 5 value and the 4 value, total 9 values are contained in the x and the y. X contains the 5 values and the y contains 4 values. The program then sorts both of them using the algorithm sort function. That the both of them, that is the x will be sorted, y will be sorted. Note that x is sorted using the function greater int function and the y is sorted without it. That's why x is giving the value in the descending order, because it is sorting with the use of the greater algorithm or the greater function, while the y is sorted normally. That's why it is giving in the ascending order, and therefore the elements are x in the descending order. That's what I said, right? The program finally merges both the arrays and display the contents of the merged array. So the program finally merged the x and the y and produces the result. Note that the form of merge function and the result it produces, that is the result will be produced. So this is the program of the function object, that is how the function object will be used for getting the x value, for getting the y value, how it will be used. This is the program. First of all, this is the sorting that is will be done on the x values. Then there is a sorting that will be done on the y values, but the difference is on the x value it will be sorted in the descending order, on the y values it will be sorted in the ascending order, and at last the values will be merged together, that is the x and the y values will be merged together. After sorting or without sorting, that will be merged together, right? So this is a program that shows what is the function object, or the how the function object will be used. And this is the explanation of the program, that is the note of the program. Now next is summary, but before this, let's take a break, then moves to the practical approach. No, moves to this one, that moves to practical approach, so that your concepts are again clear in the summary part, right? So let's take a break right now, then moves to the practical approach of the vector, list and the map container. So let's take a break right now. Break. Now let's start the session again. So let's move to the practical approach right now, or let's finish this summary so that your concepts are clear, right? So Larry, should I move to the practical approach or should I continue with the summary? Hi Larry, tell me the answer. Shall I proceed with the practical approach or shall I proceed with the summary? Okay, practical approach. Okay, all right. So let's move to the practical approach of C++. So this is a program. So this is a program that shows the vector container. So the name of the program is vector container, right? So it starts with the header file, that is a hash include iostream.h, then hash include vector.h. Then there is a line that is a using namespace std. Then there is a function that is used, that is a void display, that is a display function will be used, that is a void display. Then there is a vector, then int, then ampersand of v, then the for loop will be used, that starts with the 0, ends with the v dot size, then I plus plus, then it is simply printed the values, that is a cout, that is a cout, then there is a slash n, then this function will also be closed, then there is a int main, that is the starting of the main, then it starts with the vector, it starts with the vector, that is a vector, then int, then there is a v, right? Then there is a cout for we can say the printing purpose, that is the cout initial size is equals to, then the double quotes will be closed, that is equals to, then v dot size, that is the v dot size will be used for printing purpose, then the slash n for moving to the next line, then next is there will be a cup end, that is putting values into the vector, then one variable will be declared, that is x, then cout, that enter the 5 integer values, then for loop will be used that starts with 0, ends with 5, then I plus plus, then cin x, then v dot pushback, that is a pushback function will be used, then the for loop will be closed, then cout, that is a cout will be used, then it is displayed, that is a size after adding 5 elements or 5 values, then cout, then v dot size, then again going back to the next line, that is moving to the next line, then now next comment is for displaying the content, that is display the contents, then there is a cout, that is the current contents, then there will be a slash n for moving to the next line, then there is a display function, right, for displaying the value. Now the next comment is add one more value, then v dot pushback, that is a pushback function, again it is used, but there is a there is a underscore in between the pushback function, right. So there is a pushback, then the value that is entered is 6.6, right. Now again one more comment, that is display size and contents, then cout, that is n for moving to the next line, that is size equals to, then double quotes close, then again prints the size, that is a v dot size function with the help of v dot size function, then again there is a cout, then it is printed contents now. So now what are the contents, it is printed, then there is a display function again to display the value, then inserting the elements, and then a vector will be used and the int value will be used, then iterator will be used, that is the iterator, that is itr equals to v dot begin, that is the begin function, then itr equals to, that is moves to the third element, itr plus 3, then v dot insert, then itr, and then 1 and then 9. Now display the content, that is a display the contents, then there is a cout, there is a slash n, that is the contents after inserting, that is what are the various content that is used after inserting. Then there will be a display function that is used for displaying the value. Then there will be a v, then removing fourth and the fifth element, fourth and fifth elements. That is done by using the v dot erase, that is the erase function will be used. Then v dot begin, that is the v dot begin plus 3 and v dot begin plus 5, that is the elements will be deleted. Now again display the contents, then cout, contents after deletion, that is what are the various contents that is due after the deletion. Then the display function will be used for displaying the value, then cout end, and then moves to the next line also, then return 0. Then this is the winding up of the program, and before this we have to include the get ch also. This will be moved to the next line. Now there will be a closing of this one. If I compile this code, there are 4 errors. Unable to include the file, that is a vector.h. So if I use only this one, vector. Now if I compile, there are again 4 errors. Unable to open include file vector. So this is unable to get the vector file or unable to include the vector file. That is a vector.h. Right. So one more declaration syntax error. That is a declaration syntax error that is not correct. Using namespace std. That is not correct. So if I use the comment for this one, that is I want to give the comment. There are 3 errors. Unable to open, vector parameter cannot start a parameter declaration. So this is the error that cannot be used as a vector parameter. So this is the error for the header files. Again there are 3 errors. Then there is a expected, that is this is expected over here. If first of all if I save the program, that is a C++ program, so this will be saved by using the name, that is a vector, for example. Now if I compile this code, again there are 3 errors, that is this is not supporting one, and if I exclude this one, so there are again 2 errors, cannot start with this one. There is a hash include vector.h, that is a vector.h, that is a header file. Then there is a void display, that is a header file. So we are going to use the using namespace std for moving to the next line, that is using namespace std. If I compile this code, there are 4 errors in this code, right? So this is the hash include iostream.h, hash include conio.h, and one more header file is used, that is a hash include conio.h. If I compile, there are four errors, that is unable to open the include file, that is a vector.h. This is the error in this, that is this is not supporting one, that is a vector.h. If I again save this file with the .cpp or .c extension, that is a vector or vector.c, for example, if I save, now if I compile, there are only one error, that is a must use C++ for the type std.h. So if I change this one over here, that is a stdio.h, and if I compile, again there are four errors, that is unable to open the file or unable to open include file, that is a vector.h. So it is not supporting the, or it is not using the vector header file. If I give v as a capital, again there are four errors, cannot open the file, that is a vector.h, right? iostream, then conio.h. Now first of all save, then again compile, there is only one error, that is cannot includes the file. Again moves to open the file for the C++, that is a v, that is a vector, opening the file, that is a vector container, then vector.h, then hash include conio.h. So again there are three errors, that is expected, this is the error, right? If I remove this one, if I now compile, again there are three errors, this is not supporting one. This is also working in a Windows another format, I think so, that's why it is not working over here. So what can I do? I will check on the internet and let you know in the tomorrow's class. All right. So I will confirm, or I will get the information from the internet and let you explain or let you confirm on the tomorrow's class, that is why this is a error, there is a vector error. So if there is an error on the vector class, vector header file, so there must be an error on the list vector file or the list class or the list container or list header file. So I'm not going to forward in the practical approach because there is an error. Now let's move to the summary again. In the tomorrow class I will confirm whether this error will happen or what is the reason of this error, right? So let's move to the again come back to the summary part. So now let's start with the summary. First point says a collection of generic classes and functions is known as STL. As I told you in the first class of this STL, that is in the day after before yesterday's class, that is first is the STL, that is a collection of the generic classes and functions. So whenever we combine, whenever we collect multiple classes, multiple generic classes as well as the functions, that is known as the STL. So STL is nothing but a container, but a storage area where all the library files, all the library containers, all the template libraries are stored. That is a collection of generic classes and functions. STL components are a part of the C++ standard library. That is every standard library that is a part of the C++. So STL components are the part of C++ standard library. Then STL consists of three components. There are basic three components of the STL. One is the container, then algorithm, then iterators. Now containers are also divided into three categories. There is a sequence container, iterative container, associative containers. But the brief category of the STL that is divided into three components, that is a container, algorithm and the iterators. Right. Then the next point says containers are the objects that holds the data of the same type. That is that is the same type data will be held by the container like a array. So it is a nothing but the objects that holds the data of the same type. Then containers are divided into three categories. As I told you, there are three categories, there are three divisions of the containers. One is the sequence container, but remember in totality there are 10 containers that is divided into three brief categories. One is a sequential container, then associative container, then derived container. Now sequential container is also divided into three categories, that is a vector, list, map. Then associative is also divided into four categories, and the derived container is also divided into three categories. But the brief categories are sequential, associative and the derived container. Next summary part is, that is the fourth point I will tell you. Next summary point is, it says container classes defines a large number of functions. So in the container classes we can define a large number of functions that can be used to manipulate their contents. So for manipulation purpose, container contains many functions that will be used for manipulation of the functions or manipulation of the content. Then algorithms are standalone functions that are used to carry out operations on the contents of the containers. As I told you in the second point, there are three categories of the STL. One is the container, one is the algorithm, one is the container, and one is the iterators. So algorithms are nothing but the operations that we perform on the container class or the container object. So every object of the container that performs some operations, that operation will be performed by the algorithms. So algorithms are standalone functions that are used to carry out the operations on the contents of the container. What are the various operations that will be performed on the container, like sorting, searching, merging? So if I want to sort anything, that will be sorted by the algorithm. If I want to search anything, that will be done by the algorithm. If I want to copy any data, that will be done by the algorithm. So any operation that will be performed on the container, that will be done by the algorithm. Next is iterators, that are like a pointer. If I want to point anything, if I want to focus on anything, that will be done by the iterators. So iterators are like the pointers. If I want to point out anything, that will be done by the iterators. So iterators are like pointers. They are used to access the elements of the containers, therefore providing a link between algorithms and the container. So it's acts like a mediator between the algorithm and the container. Suppose algorithm wants the operation on the or performs the operation on the container. So there is a point, there is a mediator that performs the operation, that makes the operation between the algorithm and the container. That we can say that the mediator will be provided by the iterators, that is nothing like a pointers. So they are used to access the elements of the containers and provides a link between the algorithm and the container. Iterators are defined for specific containers and used as argument to the algorithms. So they are used for the containers, they are used for the specified containers, and are used as argument to the algorithms. There are multiple algorithms. Next point is, certain algorithms uses what are known as function object for some operations. So there are multiple operations that will be used, that will be performed by using the function object. So there are certain algorithms that are used as a function object for some operations. A function object is created by a class that contains only one overloaded operator's function. So this is the summary, that is a summary of this chapter. That is, first of all, there is a STL that is divided into three categories, that is a container, algorithm and the iterators. Algorithm or container is a simply an object that contains multiple data. Algorithm is an operation, algorithms are the operation that is performed on the containers, and iterators is a mediator between the algorithms and the containers. Right. Then these are the various key terms that is used. Then these are the various review questions about the this chapter, that is what is STL, how it is different from the C++ standard libraries. Larry, you are in the only person in this class, in this chapter, so it's your homework to read out these questions, and if there is any doubts you can ask the doubts from me. If there is no doubt, then I will ask the questions from you. All right, so this is for sure your homework. So read out these questions. If there is any doubt, you can ask from me. Otherwise, I will ask a question from you. And these are the various debugging questions, that is identifying the errors questions, that I will also discuss in the next class if there is any problem. Otherwise, I will ask the question from you. So please read out this chapter. And for sure that the problem of the practical class, that is a program is not working, not executing, I will tell you the problem or solution of the problem. All right, and these are the various programming questions, that is writing a program question or program writing questions. Now next chapter, that is the last chapter of this module, that is a chapter number 15, that is manipulating a string. That is how to manipulate the string. That is the last chapter of this module, that is chapter number 15. That is I'm going to start in the next class, that is the tomorrow's class, that is how to manipulate the string. This is nothing but the same as we do in the C. There is a string operation, there are string functions like strlen, str or concatenate. So there are these are the same functions, or there are some different functions also for manipulating the strings. So everything is same. So that is the next chapter, that is how to manipulate the string. So let's stop the class over here only. In the next class, I will be taking your next chapter, that is chapter number 15, that is manipulating the strings. All right. So thanks a lot everyone for listening me. And if there is any doubt, you can ask the doubts from me. So thanks a lot everyone. Bye bye.